Multi-factor authentication.
Yeah.
Were we warned that this was going to start happening? This multi-factor thing? Like, I got an email yesterday, but.
Oh, you did? We knew about it.
Email
From
staff.
from that meeting.
Okay, maybe I've just been ignoring emails.
Sounds like the title of Sting album or something, you know, multi-factor authentication.
There's a lot of good band names in meteorology.
Oh, there totally is.
A lot of good band names.
Well, now I'm trying to think.
Yesterday we learned
Are we
about.
ready to go?
I think we're ready to
Some
go.
names, like Buzzard Masterpiece.
Yeah.
Sounds like a bomb.
Yeah, maybe, no, not that one. Not that one, that's the, not that one. Because that's shining right on the screen.
Yeah.
I would say let's do this one over here.
All right. Okay, welcome to our weather discussion for this Friday. As we kind of trended to start doing, we're always looking at a great week-long satellite image that Pete's put together. He usually has comments about what we're seeing that I don't know about, so I always get surprised by what he's thinking. But I think this one's a little more obvious than some of the other past ones. First, I don't really know what this air mass RGB thing is, and you know, I think it's kind of interesting, but it does highlight some of the back edges of some of these cloud masses. And I'll start at the beginning of the week. This is now a week ago, February 8th. So we had just had, remind me, we just had a little ice storm, right, on Wednesday, was it, or Thursday?
Thursday, yeah.
So then this is the cyclone associated with it, and it was mostly the back edge that was kind of the culprit in our precipitation. But as Pete pointed out, I think I heard him talking about it, I noted the same thing last Friday. The extraordinary length of this cloud streak that comes all the way from an eruption of some tropical convection south of Baja California at what, latitude 5 degrees north, all the way into the comma-head portion of the cyclone over eastern Canada. So really exciting. And then the various colors, if I remember right, Pete, they tell us something about the air mass based on PV or something like that. Is that right?
They do. Back on here, go to our satellite page. You can actually get information about what that means on the page here. So this is how to interpret what we're looking at there. It works really slowly. I'm not quite sure what's going on with that.
Must be some kind of national emergency or something.
Maybe it's a national emergency. So this is what it is. So so basically what we're doing is we're taking different GOES channels or combinations of GOES channels and assigning them to the red, the green, and the blue colors of the image. So in this particular case, it's an air mass RGB. The red channel is the difference between a couple of water vapor channels. The green channel talks about ozone, and the blue channel is a water vapor again. So if it's dark in the red channel, it's moist at upper levels. If it's bright, I'm not going to go through all of the stuff, but
Well, these three here are good enough.
Three of them.
These three,
explains.
let's go back, Pete.
Yeah.
These three here are good enough.
Okay.
That when it's red or orange, it's dry upper level. And when it's greenish, it's a high tropopause. That means low ozone. So it's mostly tropospheric air that you're sampling there. And then the blue is moistened at upper levels. I'm not sure exactly what that means by upper level, somewhere between 200 and 500 millibars. So maybe unusually deep water vapor content, something like that. And then since we're using RGB, there's a whole bunch of different colors that come out of that. I guess red and blue combined means, I don't know what it means. That's when you get purple, isn't it? So you get dry upper level, but moist upper level. So there's some weird things about it.
Limb effects. But if you go to here, this has some examples of the kinds of colors that you see and what they typically refer to, what they are. So you don't see PV is more red.
Don't pay attention to the purple.
Yeah, purple is the limb effects. So I mean, you can kind of take a look at that.
So I think looking at our satellite image right here, you can see that this is largely the dry upper tropospheric air, and that's got a tinted orange, not so much red here. And then the green is the high tropopause, low ozone content. And then there are spots here where there's upper level moisture on the edge of these clouds. On almost all of them, they have a blue edge to them. And so this one is just because of you're on the edge of the viewing, it's true purple. I bet if we had a West Coast, that would be also orange and
Right.
red. So you can see in this particular example, this is a better one. They should use this as their key because it's a little more straightforward in interpretation. This cloud mass definitely separates a region of high tropopause, so subtropical to tropical type air mass, from one that's more of a polar origin, lower tropopause, high ozone and dry air. So that's really nice how that sits in there. Then when you get down here, I don't know what to say about that, but in the extratropics, you have some really nice signatures of this. So if we animate it, especially paying attention to this,
These oranges sort of trough sort of things, you can think of those sort of like what we see in Vis 5D when you show a potential vorticity surface and you see the PV surface dipping down. That's sort of what you're seeing there.
so you can watch these things. That's storm number one evolving, remaining in the tropics, of course, over the southeastern U.S. A little bit of a next wave there, and lots of stuff going on for the West Coast. We'll have to look at a regular image in a minute to see some of that. Here's the next wave that came through on, now that's the 10th, what day was that? Sunday?
Sunday into Monday.
Okay, Sunday into Monday. And that was the big snow, right?
Monday into Tuesday, maybe.
One of them was the big snow.
Yeah.
And that was the first of the couple of snowstorms this week. And then here comes the one that was our major event, which is about 8 inches of snow on Tuesday night and all day Wednesday. It just kept snowing all day Wednesday. And that's the beginning of a Tuesday. So here it is, rotating around. This time, unlike the prior storm where we were all a little bit disappointed with the low amounts, the western side of the storm filled in, and that gave us our all-day Wednesday snow. A couple of times fairly heavily. Here's one time during that, well, this is Tuesday night, but during that storm. So this thing kept filling in and giving us sometimes even what looked like convective elements, although no thunder and lightning that I noticed. But a really interesting and nicely put together storm on Wednesday. So it's been an exciting week. And I was afraid that this snow was going to just, sit around and maintain the ice underneath it. But we had a nice warm day yesterday. Got rid of a lot of that ice, so that was good. And there's the death of that event. Okay, so can we?
The atmospheric river affecting California. They've been having pretty serious flooding out there.
Yeah, some places are completely inundated, and the Sierra, the snow level keeps rising. So that's not good. They're going to start to erode some of the snow. So we'll see that. In the last 6 or so hours anyway. We'll see that in a minute in the more current satellite movie. So there's our overview of the week, and you can see it's been a pretty exciting week, a parade of storms across us, and there's been a parade of events in the northwesterly flow along the coast, which unfortunately we won't have time to really diagnose this in great detail, but it's been a very snowy week in Seattle. They had their snowiest February in 70 years, and it's only the 15th. So incredible. And I've been there when it snows heavily, and the city is a totally different place. And one time in February, it's always this kind of heavy snow, heavy wet snow, but it shuts the whole place down, and for a prolonged period of time, because usually the synoptic setting that allows for these events to develop is one in which cold air funnels off the continent, off the ocean, and stays cold. There's a lot of river valleys north of the city in the northern part of Puget Sound that ensure that it stays cold very often in those types of settings. So that was also dramatic across the country this week. So let's go now, if we could, Pete, to the infrared movie for the last 6 hours, the regular one across the central part of the United States. Can we look at the infrared instead?
Oh, I'm sorry.
Yeah.
Yeah,
So infrared, we had our little event overnight last night and brought the cold air in. We'll see that evidence in the surface map and some of the lower tropospheric maps. That was associated with this cyclone over southern and eastern Ontario. And that has a decent structure, but not the best one. We see elements of this plume coming out of the tropics at about the longitude of Hawaii, I think. So right about in the middle of the tropics at about 5 or so degrees north. Very interesting set of convective elements. It's been raining like crazy in low elevations in San Diego and further north toward Los Angeles for much of the last few days. And then another swirling mass off the Oregon coast by this time, but still cold, probably at relatively low elevations in the Portland area. You're getting snow. I wouldn't guess that the snow level's higher than lower than 1,000 feet, but not much higher than that, if even that high. So pretty interesting. We'll take a look at that on the West Coast. Right now, the weather is setting up to be rather placid for the first time in weeks for a period of days over at least where we live. Not true everywhere, but we're going to see this cloudiness that you see here across the central part of the United States is associated with some widespread snow. I'm not sure whether some of it's light or heavy. We'll take a look when we look at the odds in a minute. But that is seemingly connected to this plume from the tropics, but also maybe has an upslope component because it's on the western side of a really deep anticyclone. Some of the signature, which you can see in the cold air that's sitting on the border of the Dakotas and Minnesota, and then erodes slowly during the day. That's the center of the anticyclone that's invading from the north and west. And it's kind of whipped up the winds here over the last day or so from the northwest. So those are some of the elements that are going on across the continental U.S. and adjacent waters. Can we take a look at the Pacific satellite movie first?
Operational now.
Oh, is that right?
Yep. As of 18C on Tuesday, I think. Wow. You want the infrared again?
Yes.
Same thing.
So here's our GOES 17 off the west coast of the United States and Canada. And here's where that plume is emanating from. There's Hawaii. So this is about 23 degrees. This is coming from somewhere around 10 or 11 degrees north. And certainly seemingly connected somehow to the convection in the central part of the ITCZ and then racing forward. There was a really intense storm over the state of Hawaii this week. I think there were wind speeds of 125 knots or something at Mauna Kea or Kilauea. I can't remember which place.
Me either, but it was a really high impact event.
Yeah.
Sure. And I was thinking, yeah, the cyclonic features that far south, when you have split wave guides like this, it's just totally able to tap into.
Yeah, it just drags the tropics forward.
Yeah.
So this notion of, atmospheric river or whatever people want to call it, it's another interpretation is, here's evidence of it, deep southern penetration of an extratropical disturbance that just sucks the tropics forward. So they connect like that. And this is one of the disturbances in a whole line of them over the last 7 or 8 days that have kind of emanated around the top of the ridge over Alaska and Western Canada. Here's some of them have clung to the coast and given snow to Seattle. Some of them have broken off and made their way farther south. And so this is now the progenitor, I think, of a really impactful weather event in Southern California. The whole coast has been under attack much of the week weather-wise. It's been very interesting. So, and meanwhile, though we won't say any more about it, what a beautiful little cyclone revving up here in the central Bering Sea. I don't know if this is a crabbing season or not. I mean, for the crabs, I know it's not for the fishermen, but maybe they're kind of getting themselves repopulated. And I think this kind of turning of the ocean shallow Bering Sea really helps that happen. The nutrients are replenished and all sorts of things. So pretty wild storm. I bet you the central pressure is down in the 940s, waves are 50 feet high. You don't want to be there.
You would want to be there.
I would want to be there, so long as I was in like a see-through barrel and had an inertia seat so that I never had to really feel the waves. I could just see them. You could do that, couldn't you?
Yeah.
Maybe like a circular thing, like the Jurassic Park cots that you drive around the island. So that's where I'd like to be. Right, actually, I'd like to be right there on the back end of that cloud street. That's where the winds are whipping, because the pressure's falling out. Sorry for you. Pressure's falling out ahead of this. Pressure's rising behind it. Pressure gradient's intensifying right there. The waves are just huge. That'd be great. Okay, enough of that.
There is an Alaska crop of that too up here.
But isn't it give you at the same angle, unfortunately?
It's the same angle, but it's a closer in view of it.
Oh yeah, you get a little bit more detail, don't you?
Yeah.
What about the regular black and white infrared? Are there any swirlies on the edge here? You can't quite. I mean, the water vapor. I mean, do we have that?
Don't think I'm doing a black and white water vapor. There's color.
Whoa. Or maybe there's something even on this, except
There's
for
the heat pipe issue that you've seen.
Yeah. Sometimes you can see it might be even the obliqueness of the angle. You can see these little waves along the shear line sometimes that are really dramatic, and they're little pearls of what this is absolutely beautiful. Not this time, unfortunately. Okay, can we take a look at the radar across the country before we go to the surface map? So look at this. All this widespread precipitation on a line from far northwestern South Dakota all the way down to northern Alabama. And in some places, we'll see when we look at the odds in a minute, some of these places where reflectivity is higher, I don't know if that's not snowflakes with a little bit of water on them or if it's actually raining. We'll have to check. But on the northern edge, for sure, this morning it was snowing. And snow has encroached into the St. Louis metro area, which is one of the more highly populated spots along this line. Kansas City also had it earlier today. And maybe it's beginning to wane there. So that's the main precipitation feature we'd like to take a look at in some diagnostic sense. Here is a stream of precipitation elements sliding forward along that circulation with the major storm up in Canada. They don't seem particularly well adhered to a frontal structure or anything like that. They're just kind of in broad southwesterly flow. And we'll check on the precipitation type in the Portland and north of Portland area, mid-coast in Maine. And then if we can slide a little bit over to the west, we can see what's happening on the coast. And so here are some scattered elements within that plume of tropical moisture that's coming up. We seem to be missing San Francisco Bay to the north and the south. So Bodega Bay gets rain and San Jose, but probably it's going to rain in San Francisco. And there's a whole bunch of spotty showers. It'd be interesting to know just how intense they are, how deep they are. They're probably 10,000 foot tops. Maybe a little higher because it might have a tropical origin. The stuff on the Oregon coast, certainly, convective if it is, has really low tops, as is characteristic of that part of the world, with the kind of synoptic setting they have. So before we look at the upper level charts, and some lake effect snow, of course, in the wake of this storm that's up over Ontario, Quebec, lake effect snow in the lee of Lake Superior here in the Upper Peninsula. So great place to be, probably. I wish I lived there. But I like working here, so I can't do both. Let's take a look at the surface map, and then we'll go to the upper level chart.
Somebody on the online broadcast mentioned that there's a new AR scale. I assume they mean atmospheric river for the thing that's going on in California, and was wondering if anyone knew what scale what this event.
Oh, intensity scale?
Yeah.
Yeah, I don't know. I know that the precipitable water in some of the
looks like
Southern California soundings.
No, I don't know what this one is, but I remember thinking, why do we have category scales for ARs? But it was actually specifically requested by decision makers.
Yes, in the California water.
Okay, at least there's a reason.
Yeah.
Not sensationalizing things.
But I forget who it was now, who was on the Albany listserv, talking about the precipitable water in, I think, San Diego and San Diego area soundings was a record for November through March.
Right.
So that's saying a lot. So there's a huge transport, a record transport of water vapor into the southern part of California, at least, as measured by soundings. So here in the middle part of the country, much of that precipitation is snow. I just want to draw your attention to heavy snow in Columbia. Heavy snow to the west toward Kansas City. Moderate snow at Kansas City Airport. Heavy snow in whatever that station is, right in the southern tip of Nebraska. So there's a whole swath of moderate to heavy snow where the reflectivity was high. So that's not a water coated, probably, because the temperatures are in, 20-ish. 18 to Columbia, 16 to the west, 20 to the south, 13, 10. So this is cold. And it's snowing like crazy in some of these places. Wow, it's amazing. Not yet reporting snow in St. Louis, but they probably will. And freezing rain down near Springfield, which is unfortunate. I know one of the observers there loves heavy snow. Yeah, or one of the people at the weather service there is a snow freak, well, probably as bad as me. And it must be killing him that it's heavy snow in Columbia and freezing rain where he is. And then freezing rain also in northeastern Oklahoma. So this is a treacherous day. And then rain moderate in north of Little Rock and some lighter rain along the Mississippi. Extraordinarily warm just to the south. Look at that. Temperatures in the mid-60s, dew points in many locations above 60 Fahrenheit, sometimes mid-60s.
Yeah.
Huh?
68,
Where's the 68?
right there. Which one is that, 68?
I see 65, 66.
Okay, 65.
That's a 66. That's the highest one I see.
Yeah.
There's a 70 down there, Brownsville.
Right.
So this is unbelievable moisture laden air. And it's apparently running into some sort of a boundary in southern Arkansas, which is reflected by almost a 90-degree wind shift and a substantial temperature drop. Then it's probably shallow, and that air is rising ever so gently, and then right up over this thing, right up over the shallow cold air. So interesting. I really want to know what's going on to drive this heavy precipitation, and I can't tell from what I've seen so far, except in the very basic sense. It's not obvious to me.
And it's interesting that the orientation of the baroclinicity, the front or boundary that you can see from the Texas-Oklahoma border, east northeastward through Tennessee.
Yeah.
That boundary is, the precipitation is almost orthogonal to it.
Yeah, that's right.
An angle to it.
That's right. Yeah, it's really interesting. And where it's snowing is a local cold spot. It's in the 20s to the east, and it's in the 20s to the west, and it's in the teens in the middle. All that sublimation. Okay, can we look at the West Coast surface odds?
So I have an update on the AR scale.
Oh, yeah.
Cat 3, based on this new scale, which I think is bad, but not like terrible, but pretty bad. And a new term I just learned, the UW-AOS warned about roofalanches, which is the sudden release of snow from already snow-packed roofs, which can be a serious hazard.
How's that?
Really? What kind of house are we talking about? Is it like that castle in Chitty Chitty Bang Bang or something?
I don't know, it's very specifically like in the Sierras.
Oh, where they might have 3 feet of snow on top.
Yeah,
Oh, okay,
yeah.
okay. That's a lot of snow. All right.
Yeah, so.
So what is a cat 3? That's just based on like how much
It's,
water maybe is being used for it, or is that?
I think it's more based on the hazard it poses, so like not so bad, like, yeah, like one is, you're gonna get some rain, but that's actually a good thing versus five, where we have too much and now we're gonna be flooding like crazy in the, watersheds. So we're right in the middle of that, but I think it's still more hazardous than good.
And Cat 5 is as high as it goes, like
Yeah.
hurricane scale? So yeah, it's gonna take, anytime you're trying to introduce one of these things, it takes a while for people to catch on to what it means. And then you run the risk also, it's inevitable, of people deciding, I'm gonna emphasize the heavy rain as the reason that I use this category. And it doesn't, at first, fulfill the goal, but hopefully people will stay, on the sideline saying, no, stop talking about it that way. It means a comprehensive risk and so on. Because we're gonna have to do that with hurricanes. There's a lot of discussion about that. So that's interesting. A category 3 heavy event in the southern part of California. And it's surprisingly, very few of these places are reporting precipitation, although we saw that the cells were scattered around San Francisco Bay Area, and none of them in the sort of randomness of precipitation, observing sites actually shows any of that, but it's cloudy widespread. And then snow is that Reno, right on the border? Light snow in Reno? So 34 over 23, so there's an avalanche hazard for sure. They've had a lot of precipitation. At elevation, there's a little bit more stability to the snow, but it creeps upward, the instability, and then you've got some real problems if that goes off. I was a roommate with a avalanche forecaster for the Weather Service in the Cascade Range, and what a great job. For 6 months, you're on call all the time, and you have to know what you're doing about snow stability. You got to go out and test it, measure it, hope that it doesn't happen when you're there. And then, but the other 6 months, you get to do your research work, or for Goss, you get to ride his bike around the western United States and Canada. So it's a pretty good job. It was perfect for him, absolutely perfect for him. So light rain along the coast, associated with the disturbance offshore, as we saw earlier, and then some snow in the higher terrain of Idaho and then spreading into Wyoming. So that's light. The main thing is in the central U.S. So let's go to our upper level charts. Can we start at 500 millibars with, of course, the Super Pete, named for Pete Pokrant, our computer guy, who makes all of these, many of these graphics, and he certainly takes the observed data and gives us a really nice rendition of it. So what a beautiful map. There's a lot of things on this that are interesting today. And we saw them so nicely illustrated in the RGB the satellite movie at the beginning. So here's a deep trough right over the northern part of Lake Michigan at 12Z this morning. Very sharp baroclinic zone. So I can't read the number at Green Bay. I think it's minus 27. It's minus 30 up in the northern lower peninsula. And then in the minus 18 range, right along the southern boundary. So this is the 20-degree C isotherm. I might draw it a little bit further north to emphasize how intense that baroclinic zone is, and draw this one a little further south. So we got a pretty intense 500 millibar baroclinic zone over us at 12Z this morning. The region of cold advection is in our vicinity as well, and so that tends to mean subsidence through the core of the high wind speeds, 50 to 70 knots in this range. So be interesting if we had time to look at an upper frontal structure through there. I think we have a little bit of a PV feature hanging down off the tropopause over us today. And of course, they're stealthy. You wouldn't tell that looking outside, bright and sunny, but that's the way these things work. So
If you want to do that, we could quickly do it with tropical tidbits if you wanted to.
oh yeah, let's do that. Let's do a tropical tidbits cross section through there from like Sault Ste. Marie down to Des Moines or something, or maybe longer, just to get a better aspect ratio. Because all you do is you just draw the cross section and then it does it. Okay. So I was trying that the other day. Remember I was telling you? I forgot. I thought there was like that.
So ready, let's go.
Let's go from up here in southeastern Ontario straight down to like. Maybe right here. Yeah. And straight down to maybe Kansas City. That's perfect. Even a little longer so we get a nice picture. And then let's look at PV. I think it also brings theta along for the ride, if I'm not wrong. And this is from 12Z?
Yes.
From a 6-hour forecast though?
Yeah.
Okay. Wow, must be some sort of emergency. Sorry, I already used that. Okay, so to get you set, this is north, this is south. So what a beautiful cross section. There's two little pendants of PV. This is the one I think we were aiming for, over about 45 degrees north. So green is theta, every 5 degrees. The isotax are in meters per second, I think. Is that right, or is that knots? That's got to be knots.
It's not.
And then in purple, and then the PV is colored in with the 2 PBU isoline, I think, in the dash. So this is a well south. This is well, not that well south, a little bit south of us. And this is the feature I think we were interested in. So there's a nice jet feature. We'll see that when we go to 300 millivolts. That's right where the core is. And a nice PV pendant. So historically, there's almost surely been some subsidence along the 315, maybe the 300 degree Kelvin isotope, dragging the stratosphere down to as low as, look how far it goes down, 580 millivolts. It's pretty nice. And then this one here to the south with 110 knot wind speed max at about 230 or so millivolts, probably a subtropical jet with a not so, I don't know if that's true, with a not so deeply protruding pendant, but almost as deep. Baroclinicity is weaker. You can see the gradient of theta is not as strong, nor is the stability. That makes me think it's maybe kind of connected to a subtropical feature. Okay, and this part of the cross section is in the vicinity of our band of heavy snow, which is kind of interesting. So we'll see what that looks like in lower troposphere in a minute. I think this is a clue about what's going on there. Okay, thanks, Pete. Let's so we're going to be before we leave 500 millivolts. We saw a really nice upper disturbance off the coast of Washington and Oregon, and it also has a fairly intense baroclinic zone on its western side. Without any observations of the winds, one can probably guess these winds are in the 60 to 90 knot range. The gradient, the geopotential is really strong. And then strong westerly flow all the way across the southern tier of states from Southern California to southern Georgia. And that makes it warm in central Texas, and it probably makes it wet in the southwest, and it probably sets up something that's on the wet side in the southern states as well. Okay, let's take a look at 700 millivolts. 300, sorry. So we just have a cross-section look through about like that, and we saw a little bit of this polar jet feature at something like 47 degrees latitude. Look at this subtropical jet feature straight across. It's zonally oriented from the Mississippi River to who knows what, Mount Kilauea. That's an incredible feature, hooked up as it is with this polar feature that's certainly independently racing southward out of this ridge in the eastern Bering Sea. So this is a really interesting spot. So, little soapbox here. Atmospheric river, it's more than that. It's a conjunction of a whole bunch of things. A subtropical jet that's zonally oriented, an upper wave that's coming in over Southern California. It's more complicated than just, saying it's this one thing. Very interesting.
But isn't the convection from the atmospheric river helping erode the PV on that side and then helping form a jet?
That's quite possible. That's quite possible.
I guess it'd be more
The jet, when you look at, my tropical plume page and stuff like that, the jet is actually part of a very, very broad tropical plume that goes all the way across. It almost looks like an extension of the tropics up to that level, because rather than being a narrow plume, it's this broad
Is that right?
area of extension of the tropics,
Yeah.
and that's why it looks so straight.
And this is on the poleward edge of that?
Yeah, that's
Yeah.
the poleward edge
Yeah.
of this broad extension of the tropical tropoplaza.
Yeah.
But right at that extension over the western side of it in there, there's a lot of breakup, what we call it spokification.
Yeah.
Going on in there. It's eroding the jet from the loss of.
Oh, yeah, that's all on the anticyclonic shear side of this feature.
Yeah, right, and that's
Yeah,
all
yeah.
being eroded and broken
Yeah.
into gravity waves. So, I mean, it's an interesting situation. I'm not quite sure how to characterize it because it's so broad. It doesn't
Yeah.
look like a normal plume. coming
Well, and I'd say this, I was thinking as you began your discussion, and Melissa's comment too, embedded in here. If you were to, and we do once a week for, 30 weeks out of the year for 25 years. That's like 700 looks at the 300 millibar winds roughly during the cold season. How many times have you seen this out of those looks?
You
Maybe
see it a
never.
lot, but a lot further south.
Oh,
and out
yeah,
in the
well, that's what I mean. I mean, the
Yeah.
whole thing, move it to the right latitude.
Yeah.
Yeah, this is extraordinarily unusual, I would say. And I think there's probably a way to actually verify that numerically. But that'd be my first guess. This is a really unusual pattern. And it's going to have ramifications for the whole southern half of the United States, it looks like, and maybe especially on the West Coast. So all these comments are excellent, and it really points out how fruitful it would be to investigate this case in detail, to see kind of what conspired to make this really anomalous picture that we're seeing here this morning in our discussion. Everything else aside from that is not that anomalous, but that's really standing out there like a sore thumb.
to add to the complication, there's also a storm injury.
Oh, is there? And in what phase is it?
Right now I think it's phase 7.
So that's really far east, right? Is that right, Stephanie?
That's in the West Pacific.
Okay, the West Pacific.
But it's currently in phase 7, right? So we're probably being impacted by like phase 5 or something.
So outflow from a prior time. Yeah. So what longitude, remind me, what longitude would a phase 5 convective feature be at roughly?
So phase 5 would be, I don't know about the longitude, but it would be over here.
Oh, okay, so like 120 degrees east or something, 100 degrees east, okay, that's pretty far east. But then, yeah, but that's, as Greg's pointing out too, and it's in concert with your comment, that can really produce this odd tropopause structure that's pushed forward, and then it can become zonal. And it looks like we're on the far western and eastern end of such a thing. We're fascinated.
See, can you shift over to this Jake page once? I want to point out something on the,
Here,
on the Walker circulation.
Also, while that's coming up, another question related to this is, earlier this fall, we were talking about the possibility of being in maybe a weak El Nino pattern.
Yeah.
I'm wondering what's actually,
oh yeah,
what's happened? to
what is the story then?
In which,
Is it strong
Go
or
down
weak?
to the
Jake had one.
cod field.
Just like you can do that.
But I'm wondering, is it first strong as was anticipated, and is the structure of it kind of a classic, I mean, if there's such thing as a classic El Nino, is this?
Yeah, I'm trying to think, I don't know where it's at right now, but I think it's.
Okay, this is the high level chi field, okay, velocity potential. And the blue is the negative chi where you have net upward motion in the troposphere. So this level here is about 14 kilometers. So you're at the very top of the troposphere, and these are the jet streams. So here's that subtropical jet that we were looking at. And here's the polar jet.
Yeah.
Meager.
It's what?
It's a meager polar jet.
Yeah. We're
We don't even care about
burning
this.
for battle. Well, you care about that if you're in San Francisco Bay.
It's a subtropical jet, but this subtropical jet is being fed by the upward motion from this Walker circulation. I would imagine that some of the outflow from the convective systems over here is coming over here. But this is where all the rising motion is, and you'll notice this is shifted well over to the east from its normal position, which tends to be more toward the maritime continent. So this is almost like a southern oscillation pattern shifted over, but it's not going to last. But that seems to be feeding into what's going on with the subtropical jet and this subtropical jet over here as well. But Pete, if you animate this, see what's going to do over the next week.
so just to explain, these were, you're initially starting with analysis from 6E this morning, and this is
6E this
not going out.
morning, and then this is into the
Next
next week. And what you see happening is it's shifting back toward where its normal position is. So I don't know why it was shifted over, but, and then the subtropical jet is moving across and is becoming all sinking motion here in the eastern Pacific. And then this is shifting back toward the maritime continent. So I don't know why it's in a position where it is right now, but it is an unusual position.
Yeah.
Right,
So
just
there's, on many scales and many different locations, there's a lot of really unusual characteristics of this current event.
Right. One other thing I want to point out is that you notice as this jet slowly progresses across the country, it kind of arches up over the southeastern United States.
Yeah.
Near the end of this.
Yeah.
Yeah.
You can see it's sort of a hump type feature, this big ridge
Right there.
that develops in there. We're going to see that maybe just very briefly in the forecast. It shows this tremendous, huge gradient slope to the tropopause right over the sunshine.
Oh, is that right? Oh, that's good. So if you're in the left jet exit region of such a strongly sloped region, you might expect a lot of rising motion like on Wednesday.
Yeah.
Huh?
Yeah.
You know, you would,
Cold air to the north, you don't want that.
with all that subsidence on the south side of that jet later on in the period,
Right in here?
yeah, see all that red developing in there. I mean, it seems like it's a jet that's putting its energy back into potential energy, forcing substance rather than growing.
Yeah, right. I guess that's one
It
way.
seems to be spending its, whatever it built up over time when it was associated with that blue.
Yeah, so the barotropic exchange can go in either direction.
That's
We
right.
kind of emphasize the ones that make the jet stronger, but they
Yeah.
can go the other way. That's interesting. That's a lot going on here, and I think we're not quite there, but we're like a month away from the transition season, where I think some of this stuff really gets lit up. And these players start to take on outsized roles as more of a common situation. Maybe this is the first example of that type of somewhat amplified interaction of these things that occurs in the mid to late winter. So this is really interesting. Okay, we were at 300 millibars, right? I think we were going there. I'm almost done. So, yeah, 171. Let's just go for the fun of it to 200, because we know this is probably a subtropical jet. I'd like to see what it looks like at that elevation. Look at that. 185 knots, 183 at San Francisco. Or not San Francisco, south of there, but incredible. What an incredible jet feature. And on the northern end of it, this upper disturbance, which is swirling around, we saw in the satellite pictures, spewing precipitation across the Pacific Northwest. And this thing here is just supercharged. And if you're in, Southern California region, you're in this incredible region of upward motion forced by the acceleration of the jet there. And it's no wonder it's been raining ceaselessly. What an amazing event. Okay, and then let's go down to the lower troposphere, 700 millibars, 2 more levels, just to see if we can make any reasonable diagnosis of our snow band, which at about 12 Z was like this. And so here at 700, I don't see any obvious baroclinic structure to this, though there is a clear trough upstream of where I put my pointer, which is the axis of the snow band. Downstream, and the wind directions are changing 90 degrees in some locations. So downstream of that trough, certainly one might expect some upper divergence in a line because the trough line is slanted like that. So it might just be something as simple as that that's driving the precipitation there, in combination with maybe some stability characteristics that could be assessed by soundings. Let's see what it looks like at 850.
So imagine if you have a lead trough, you have such a strong jet.
Yeah, that's right. That's right.
Yeah,
So
there it is.
that's right. So here's some lee trough structure that's associated with this jet roaring across the southern states. And
There's your upslope too.
yeah, there's upslope as well. The anticyclone at the surface is right about here, and so the flow is like that. So you got upslope flow contributing to some of the earlier in the day precipitation. How does it maintain itself as it moves down the slope to the east? Maybe a function of some of the drier and more standard dynamics that are kind of just a function of the odd orientation. At 700 millibars, that little bit of troughiness is undoubtedly the manifestation of the lee side feature at that level. It's much more dramatically manifested here at 850. And at 850, closer to the ground, you actually also have the upslope component. So it's a complicated weather system. If you're in western Kansas, you've also got really intense warm advection around the central part of the state of Oklahoma. You're going from something like 15 degrees to -8 by the time you get to Dodge City, and that's going straight up the slope of isotropes. There's a lot of ascent going on there. And that's about where we had one of our reports of heavy snow. So an interesting day. As cold air at low levels funnels down along the Rockies, you can see it's banked up against them. Strong flow across produces the lee side trough structure, which induces some upslope flow at low levels, but also produces a mid-level trough, which reinforces the upslope in some longitude bands in the central U.S. Fascinating example of the interaction of the topography with a really intense tropically driven jet. Absolutely spectacular. An example of the kind of things that we talk about every Friday, and we start listing as possible research questions. And sometimes people go off in their labs and start scribbling away and thinking about it. That's what's so fun about this. So we don't like to tell it to all the audience online because you've got to play like this when you're at the pulpit. No, I'm kidding. We talk about all those things.
Right.
So they're a good question. Okay, that's all I have.
I think, Greg, you want to talk about that windstorm?
Oh, Pete can bring up
Yeah,
the,
if you can bring up the,
I wanted to just throw this up too. Ed has updated for us the yearly climate data, and if you look at the snow,
Oh, you were over the average, yeah.
yeah,
we've crossed.
yeah, the last couple of weeks have been pretty crazy.
Steep slope, yeah.
so we got an email yesterday, I can't recall who sent that.
Ryan Clare, I think.
Okay, yeah, Ryan Clare had sent a cross-section of there was a Delta flight, 5763 that made an emergency landing in Reno yesterday. We had the turbulence of the Sierras, and someone had made this cross-section on top of this, and Ryan was just interested in maybe a brief discussion of it. But Greg would be great to do that.
Well, this is a downslope windstorm, apparently. Now, where was the airplane landing?
It's Reno, so near this, yeah.
Up in,
Right there.
It's supposed to go to Seattle.
somewhere around here. So I'm guessing these are gravity waves up here. This is up and downward motion over the peak of the mountains. And this is a kind of a classical situation. particularly if it was reversed, but the wind's going from left to right, I think in this case here, it looks like east, right? No, that's what it,
This cross section is backwards from the one we looked at before. A is out over the Pacific, and B is.
Yeah, it's further in.
Nevada.
Yeah, there's a cross section right there.
oh, so these are westerly winds,
Yeah.
these are not like pictures. Okay, anyway, this is a, classic setup. It looks more visible over the Rockies. This would be the peak over Rockies, and Reno's out here, I guess, right?
Yeah, kind of north of there.
So the Sierras are off here, and this.
So that's actually, it is through the Sierras. So you
Yeah.
can see the cross section upper right
B,
as well in the
A is the Sierras?
No,
A is on, A is,
specific, yeah.
oh, this is the ocean here, okay.
Yeah, yeah.
So Reno would be right here.
Yeah,
Yeah,
but further north, but at about that one.
Out of the cross section.
Okay, so yeah, all right. Either way, this, what you see here is an inversion and cool air trapped at the ground. Another inversion up here in the high levels. You got wind coming across. Now, what's happening here is wind's coming up over the barrier. It's becoming negatively buoyant and then crashing down the other side, initiating these gravity waves here. Now, these gravity waves tend to be trapped by these inversions down below. So they build up energy at low levels. This up here, this is up and downward motion. You see it going up to very high levels, even in the stratosphere. So this is a very high amplitude gravity wave. The way I like to think of this is you have water coming down a stream, and water in a stream is, of course, stable in the sense that it doesn't just go up in the air. The higher density of the water keeps it down there. You can think of this inversion, cooler air near the surface as a higher density air at the ground. And when it's being brought up over the top, and it's shallow compared to the height of the mountains, it crashes down the other side and forms a hydraulic jump. Now, this one doesn't really show the hydraulic jump. It might be right in here. But the hydraulic jump occurs from the water coming up over it and crashing down the other side and forming kind of a hole. It's like when you're in a stream and water's going over rocks, it's not very deep. It produces white water. Right? It goes over the rocks and crashes down the other side and digs a hole down below the rocks. So if you're in a raft coming across here, you would be pulled down into that hole and producing very high winds in the air as a result. This tends to happen when you have these shallow inversions, particularly up here. This shallow inversion about the height of the mountains is a classic situation to do this. It's like with white water. You would not see the white water in those holes forming if you have very deep stream. So you have to have the stream at a level about the height of the rocks. Then you get this white water effect. So the fact that this inversion is very similar to the peaks of the mountain is causing this to form a hydraulic jump in here. And I think you can see with these isotropes that there's some kind of a ball jump in here, a hydraulic jump, where it's pushing the isotropes up and digging down in here. Unless you're exactly in Reno, you're not going to see it exactly, but it's certainly the situation up here that would produce that sort of a thing. And the fact that you got these deep gravity waves going all the way up is another indication that you're getting deep tropospheric waves. There's two modes of trapping of these waves. One is by the tropopause itself, and the other is by this low level inversion, and they work together.
I think you can kind of see them, and I made a mesoscale loop of the mid-level water vapor. This is the 1 minute imagery yesterday afternoon. There's a break in the middle because of the bad imagery. You can see all these little wave things going on in here. Again, scopeification.
Mm-hmm.
So there's the jump an hour later. This is around the time when the
So
plane.
Reno's right about up here.
Yeah. So the plane was diverted to Reno. It was over the Sierras where it had the problem.
It's heading.
Oh, it was over the Sierras?
UCF.
Yeah.
So they were actually experiencing those deep gravity waves.
Yeah, then they have to get out of the sky.
Above, yeah.
In control of that.
That's what you're getting over here. Another interesting aspect of this is what is the effect of this tropical plume? Because as I was saying before, the tropical plume is down here, tropical boundary, and there's that scopeification on the northern edge of it. I don't know, this seems a little far north to me for that.
does the reduced stability south of that plume help foster the upper propagation of those gravity waves? Yeah, so you have this very shallow, stable layer right at, at the peak of the mountain, and then you have this broad subtropical air mass that's very low stability that's above it.
Well, the stable layer down below is going to be producing a hydraulic jump and strong winds at the surface, if you get that. But if we're talking about an airplane, that would be the deep gravity waves way up at the top that are coming up from below. And those gravity waves are a process that occurs where,
There's kind of standing waves right in here. Yeah, the ones that are not propagated, they're kind of just standing still.
yeah, those would be the mountain waves, if they're not propagated. Yeah. So they're initially trapped by the tropopause, but as you trap them, you can create a neutral layer up high, which traps things even more, which is probably what's going on with that. And then you get excessive trapping, you get very high amplitude gravity waves. But these, of course, look pretty high amplitude when they show up on that. Very stationary. Yeah, well, it's probably initially tropopause trapping, and then initial secondary trapping on top of that, resulting from the turbulence that occurs up high and mixes it out and creates a neutral area that traps them even more.
So basically, you can't run a 180 knot jet at 200 millibars across the Sierra with low stability on the south side and expect to have no consequence.
Well, the conditions are that, yeah, the conditions are to have high stability near the ground.
But not above that.
But
Stable
low
minutes
stability above that.
everywhere else. Yeah,
Right,
yeah, okay. So you had to have a predecessor cold event, sort of.
You need a cold pull at the surface.
Yeah, at the surface. And then on top of that, if the tropics comes over on top of that with a strong wind speed, you got real problems.
Yeah.
Yeah, okay, that's interesting.
In Colorado, when you look for downslope windstorms, they tend to occur when you got cold air trapped in the Great Basin.
Yeah, and a strong flow over the crest,
The
yeah.
eastern slopes.
Yeah.
This is a little different. You have some cool air from the marine boundary layer on the western side of the mountains. And then you have the cool air trapped in the Great Basin. But together, they're that stream effect.
Yeah. All right, Michael had to leave, so I'll give a very brief forecast. And we'll just run through the maps you make for us, Pete, at 500 millibars. Thank you, Greg. And thank you, Ryan, for bringing that to our attention. There it is. So let's take a look at every 12 hours. We'll start at 6, which is about where we are now. So here's our 500 millibar map, 6-hour forecast approximately at this time. So we've already seen this feature in the satellite movie. I've got my eye on this one on the western shore of Hudson Bay. I have a bad feeling it's not going to make it this far south at this longitude. It's going to end up there. And here's the big wave that's from the extratropics anyway, over the Pacific Northwest. And we already know that there's this incredible jet just to its south at a higher elevation. So there's confluence of these two features across California, southern Nevada, and then New Mexico and Arizona, Utah and Arizona. It's going to be interesting over the next several hours. So we'll trace how some of these features move across the country over the next couple of days. Maybe we'll go out as far as Wednesday. So let's go 12 hours ahead. Whoa, what happened? We got a difference in the color scheme or something? Oh, this is one of those ones where something's just wrong in the model. Let's do a 3 hours past this. You can tell when the winds are a little bit funny. Yeah, okay, so here we are at 3 a.m. tonight. So in this strong northwesterly flow, one even sees on the semi-synoptic scale, or small synoptic scale, break of this shear line into little vortex structures. And they show up as little individual vorticity features. And they are, of course, sitting, of course, on top of that jet. So there's going to be some interesting interactions between all of these things. Each one of them a fairly potent, probably but local association with weather, active weather. This one will be with convection off the coast of Oregon. This one just off the northern California coast, and this one in southern Nevada. So we'll see on the surface map in a minute what that all looks like. Over us, just a hint of some structure in the shear line that probably had something to do with our snow this morning across the central United States. And then the leading feature in that whole line is a barely perceptible curvature maxima in the flow here over Kentucky. So we seem to be in the clear for the near term, and I'm talking about tonight and tomorrow. And there's not particularly obvious upstream disturbances. This one is probably the feature of interest for us on Sunday. Let's see what the surface map looks like at this time. That's 18 hours in the forecast, or 21, it was 21. Yeah, we had to go ahead a little bit, sorry.
Slow, very slow.
Okay, great. So as we maybe had a little bit of an intuition about, here's precipitation feature number 1 tied with the disturbance at 500 millibar off the coast of Oregon, Washington. Here's the one in Central California, and then there's something just to the north of the feature that was in Arizona at 500 millibars, and there's the cyclone minimum sea level pressure. Undoubtedly, part of the lee side pressure trough, especially evident in Wyoming and parts of Montana. So complicated weather system, and 3 little disturbances show up even at sea level, and we are enjoying just weak but persistent cold advection with the anticyclone to our north, a finger of it pointing down into the Missouri River Valley. So we have a little bit of flow from the north, but not particularly strong. Okay, let's go to 12 hours past that, so it'll be like 6 hours, right? 30 hours in the forecast. And by this time, so this will be midday tomorrow, by this time, this whole collection of smaller scale structures seems to have opened up into a broad trough over the western half of the United States. And we're getting ourselves into a position to be downstream of the leading edge of that curvature maxima. And so that, at this time, that leading edge will be along the Missouri River in Nebraska, parts of Kansas. And we're going to still be enjoying a pretty boring weather day through the middle of the day on Saturday. So let's see what that looks like at sea level. Yeah, so giant anticyclone sitting over us, just about 0 wind. Here's a disturbance trying to get itself put together in eastern Colorado. I think that's the one that has a address for Sunday. And then generally unsettled across the Pacific Northwest with a strong anticyclone off the coast and weak troughs of pressure along the coast itself. Now the temperatures are not close to cold enough for snow any longer at low elevation. Probably in Portland, certainly that's not the case in Seattle. So it's going to be raining if it precipitates at all in the Northwest. Okay, let's go to 12 hours further than that, so 42 hours. By which time, again, this is just a broad upper trough that occupies most of the western half of the United States with an embedded shear vorticity maxima, so a jet feature undoubtedly coming off of the continent over British Columbia offshore. So it might be a replenishment of some chilliness over Seattle and Portland. And we are closer to, this is now midnight Saturday, we're much closer to being immediately downstream in the leading portion of the curvature maxima, which at this time is located over northwest Missouri. So things may be changing for us by the time we get to this point. Cyclonic curvature and then anticyclonic curvature, maximum and upper divergence over the nose of Iowa and northwestern Illinois. So imposing itself upon us. Let's take a look at 300 millibars just at this one time to see what that jet feature looks like. Slow to it. So here's what we saw this a little bit on Greg's animation earlier, but we got a little bit of a close-up view of this now. This is an extraordinary jet roaring across the southern plains of the United States, 171 knots near the Panhandle of Oklahoma. And north of that is where we are. We're on the exit region of that. The wind speed maxima decreases rather rapidly across this region. And so in this location, there's at least a little bit of transverse forcing for ageostrophic divergence here. Couple that with the divergence from the curvature, that's a pretty good spot to be if you want weather on Sunday, Saturday night. 130 knot jet off the coast, which gave rise to that little shear vorticity maxima off the coast. It's kind of less impressive than I thought it would be. That's strong wind, but it's kind of a weak feature. It doesn't have very much speed variation along its entrance end or its exit end, so there's not going to be a lot of transverse ageostrophy tied to that. So let's see what the surface map. No, we already did that, didn't we? We want to go to 500 millibars at 54 hours. This will get us to midday Sunday. Maybe it's too big a jump. Here's the vortex strip on the back side of this really broad open wave that pretty much now occupies 2/3 or more of the continental United States, with all of the weather disturbances tied to it, kind of riding on the forward side of that jet we saw at 300 millibars. And maybe they're just getting stretched out. None of them can wrap up because there's so much stretching deformation along the jet. And so I'm not sure what I'd say about the interval between the prior 12 and this one, but it does look like this weather feature, this upper vorticity feature, is predominantly a shear feature and is to our south. So I might guess that if there's active weather, it's over the nose of Iowa, northwestern Illinois at this time. So let's see what the sea level pressure map says at 54 hours. So this broad I guess that's the focus of some of the heavier precipitation, but there's a broad region of light precipitation. All of it snow. The 540 line is well south of this whole region. So this will all be light snow over us by, midday, and it's already started, of course, by this time. So early in the morning, Sunday, through the period of midday. The cyclone seems to be developing more in tandem with the jet at 300 millibars than the 500 millibar vorticity structures, which are actually to its northwest. So it might be a reason why this thing is having a hard time getting itself organized. It's being attempted to be governed by two separate masters, and it doesn't really know which one to pay allegiance to. And since it has no volition, it can't make up its mind. And how about an 850? We haven't seen that yet, 54 hours. Not all of them are slow. Occasionally one of them comes in slow. And as a consequence of the sort of lack of development of a really intense central pressure minimum, what we have, I think, for Sunday is a broad baroclinic zone. You can't see the arrows as well as I can. I'll just point out in central Illinois, these arrows at 850 indicate very light winds along the isotherms, so from the southwest. And then over southern Wisconsin, they're cutting across ever so slightly, but they're coming straight from the east-southeast. So there's about a, 110 degree or 120 degree wind shift across this baroclinic zone. So that's weakly frontogenetic, and that's enough to produce a thermally direct circulation, the air rising on the warm side, and then precipitation falling as it is on the cold side. And that frontogenetic activity is evident all the way through this sort of troughiness through the Dakotas and into western Iowa. So there's some reason why the precipitation seems to be extending out to the northwest in association with this not so well developed and struggling to develop disturbance. But it puts us in the crosshairs for Sunday afternoon for some light
It's
snow.
interesting with all the southerly winds on the eastern side of that,
Yeah.
across that baroclinic zone. So is there going to be a lot of precipitation in the south, in Kentucky, Tennessee?
I don't know. My guess would be it'd be more middle Atlantic, so we can go back and take a look. I didn't pay
Oh,
attention
because
to
of the
that.
divergence.
Yeah, because it's differential temperature convection here. It's more or less uniform here. But this is closer to that tropical plume in the tropical moisture zone. I'm going to guess that most of the precipitation on the eastern side of the storms over the middle Atlantic. Can we go back and see? No, you're right, Greg. So not very much in the middle Atlantic, and it's emphasized instead in the region that's closer to the intense jet. And there's a local convective maxima there in central Mississippi on the border with Alabama.
What's interesting to me about this is that high field that they're showing in the prediction was showing subsidence there to the south a lot. So there's like dynamic subsidence, and this is occurring from the baroclinic lifting at low levels under that dynamic subsidence.
Yeah, so it's not encouraged by the large scale, but it's not prohibited.
It's like
Yeah.
precipitation, but the atmosphere is hard as an inch.
Yeah, right, right. And that's kind of the picture of this whole storm. It's not really got its teeth out. It's not really going for the goal line on this, in a way. And I think that continues. We'll do maybe, we'll go up to Monday morning. That'll be enough. Everybody's been here a long time. It's been very patient. Wrong time. Maybe I'm wrong. No, you're right, Pete. Push your
That's midnight.
So this is midnight. And look at this, Greg. All these regions of negative absolute vorticity. These are all just plumes of, boundary layer, unstable air that's kind of been ejected forward, upward, and then they have to manifest themselves as those. So those are signatures of convection. And this is widespread on that side. It's everywhere.
Well, here's.
Well, look at this. This is the low PV from the subtropics congealing into this anticyclone. Isn't that cool?
Well, here's something back to your earlier comment. This we have all this negative sinking motion occurring as the Walker circulation withdraws, right? So are we back now to saying that the MJO might have been causing all the interesting weather we had in the first place, and now it's withdrawing, and so we're going into this period of not much going on?
I don't know. It could be. Stephanie just left. It's too bad. She would have to have heard that comment probably. No, that could be. That could very well be. I think the way the extratropics have carved themselves out to fit perfectly hand to glove to that jet is spectacular. And that's led to boring weather on the north side, maybe, but pretty interesting and convoluted weather on the south side of that. So let's just see what the sea level pressure looks like here. I think we're going to be done with our snow by the time we get to late day on Sunday. Yeah, a little bit of light snow hanging around at midnight. And then a few convective elements, especially here on the coast of North Carolina. That's going to be interesting. A place where, I don't know if it's too early to start thinking about a potential outbreak, but maybe there's going to be something, I don't know what SPC thinks about the weekend for the southeastern United States. But I don't think it's crazy to think that there might be something unusual going on for this time of year down there. That might be the manifestation of it in the model. But it's very much constrained by the large scale, as you point out. The large scale is working against it. And local jet scale and synoptic scale are trying to resurrect something in that location, and they're fighting the battle.
Well, I think one thing we're doing is we're approaching this annual singularity that occurs around the end of February typically, maybe a little earlier this year. And what happens at that singularity point is that we start switching from tropical plumes, trying to use the northern hemisphere, we start going to the south.
Oh, yeah.
And we start emptying out the potential of the tropics.
So withdraws from the circulation of the northern hemisphere, is what you're saying.
Right.
Yeah, that's interesting. I don't know. It's really interesting. And is there anything that compels it to encourages it to go along its path in that direction? You know, like a weakened polar vortex or some of that other stuff that happens seasonally? Do they work in concert to kind of push it all out?
Yeah, like the quasi-biennial oscillations, that's anything to the kind of, you know.
Yeah, I don't know. I mean, the QBO this year was it's easterly, isn't it?
I actually don't know.
I don't know.
I think it's easterly right
Yeah.
now. Or no, no, it is westerly.
Oh, it is. Okay, so that's the anomalous, right?
Well, no, it's every other year.
Oh, but I mean, it's the westerly flow at that latitude anomalous.
Yeah, but the QBO is only right around the equator.
Oh,
So but it affects everything else, so I don't know.
Yeah, it affects the MJO.
Oh, yeah?
There's been a lot of really strong MJOs, so westerly I think would make sense, because
Yeah.
that's interesting.
more active.
That's really interesting. So the key is, did it do anything in mid-January to change the complexion of it? That's
Well,
kind of an
the one thing
interesting
that's really different this year is there's no polar night jet.
Well, it was it destroyed by
It was
that
destroyed by
warming
the,
event?
yeah, it was destroyed by the sun-stratospheric warming.
Never
There's
was
none
able
up
to
there.
regenerate?
As far as I know, I haven't noticed it.
Yeah,
But
that's really
maybe if I look now, it's there, but I don't think it's there.
So I think the weekend gives us some snow on Sunday, and we enter the week with some, a transition over the continent. I won't show you, but it looks like Wednesday could be another snow event. And then in the longer term, yesterday anyway, all the way out to 27th of February was a really substantial snow event. So that's possible. So we have to keep our eyes on that. We'll talk more about that next week. All right, thank you, everybody, for your attention. Greg, thanks for the stuff on it. Ryan, for the stuff on the gravity wave. And Pete, as always, thanks for driving. So, excellent. See you all next week.
Yeah, we don't have a polar night jet.
That's interesting.